Hi class, how are you today? Well, that's not a very rational response. The learning target for today is to simplify square roots and rationalize the denominator. So two separate things that are very much connected. For your scale, for a 3, you can simplify square roots and rationalize the denominator. 2, you can simplify square roots or rationalize the denominator, but not both. 1, you can partially do one of these, but your answers are often not fully simplified. So you'll simplify it a little bit, or you'll do some of the rationalization, but not simplify it all the way. And 0, you cannot simplify square roots or rationalize the denominator. Let's get started. All right, before we start with simplifying square roots, we're going to need to use the perfect squares. So, in case you don't know your perfect squares, here's a list. So, perfect squares are numbers that are a result of a number being squared, or a number multiplying by itself. So, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4, 5 times 5, 6 times 6, all the way up to 22 times 22. So, obviously there are infinitely many squares because you can go up to any number and then square it. I put the first 22. Now, we start off with the first problem, square root of 20. So if we have the square root of 20, we want to simplify that. The way you simplify it is you think of the factors of 20. What is a perfect square that you can divide out of 20, or is a factor of 20? So, always good to go down the list. Ignore 1 because 1 works for every single number. So, you don't have to take 1 out. So, we start with 4. 20 divided by 4 is 5. That works. So, all we have to do is say we take out 4, still under the square root, so square root of 4. And what is left over when we take out the square root of 4? When we divide 20 by 4? Well, 20 divided by 4 is 5. So we've got square root of 4 times the square root of 5. Then you take the perfect square and take the square root of it. What's the square root of 4? 2. And the square root of 5 you can't take the square root of nicely, so that stays square root of 5. So 2 times the square root of 5, or as many people say, 2 square roots of 5. Now let's look at the next problem, square root of 32. So once again, we look, ignore 1, can 4 divide 32? 32 divided by 4 is 8. So yes, that works. So notice there are two ways to do this. Let's do this way first, and then I'll show you a different way to do it. So you take out the square root of 4, then 32 divided by 4 is 8. So we've got the square root of 4 times the square root of 8. Then take the square root of 4, which is 2, times the square root of 8. Now you have to look. Is there a perfect square inside of 8? So again, 4. 8 divided by 4 is 2, so that works. So here's what you do. 2 times the square root of 4 times 8 divided by 4 is 2. So 2 times the square root of 4 times the square root of 2. So that leaves us with 2. The square root of 4 is 2. And times the square root of 2. Now we multiply these two. 2 times 2 is 4. And we're left with the square root of 2. So 4 square roots of 2. Let me just circle the answers. Now, like I said, there's another way you can do this. So you look through, 4 works. 4 is a perfect square you can take out of 32. However, there might be a bigger one. 9, no, that doesn't work. 32 doesn't divide by 9. 9 isn't a factor of 32. 16, though. 32 divided by 16 is 2. That works. So you get square root of 16 times 32 divided by 16 is 2. So the square root of 2. And the square root of 16 is 4. So 4 square roots of 2. So either way, you'll get the same answer. This way might be a little bit quicker, but it involves you trying out a whole bunch of different numbers. Alright, let's do one more example. 2 times the square root of 75. So the 2 is going to stay there. Just like when we reduce this up here, same thing, the 2 stays right there. And we're going to multiply that by whatever perfect square we take out. So, square root of 75, we have to think of what perfect squares can we take out of 75. So, looking through, 4 doesn't work, 9 doesn't work, 16 doesn't work, 25. 75 divided by 25 is 3. So we say 2 times the square root of 25 times the square root of 3. Then 2 times square root of 25 is 5 times the square root of 3. So 10 square roots of 3. Alright, so that's all you do for simplifying. All you have to do is find the perfect square that you can divide out, then take the square root of that number, multiplying it by whatever it divides by, and whatever the square of that number is times the square root. Now let's go to rationalizing the denominator. Alright, so like I said, if we have square root of 3 divided by the square root of 5, we're not allowed to have square roots on the bottom at all. Can't be in the denominator. So, what we have to do is we have to change this so the square root is not in the denominator. The problem is, the only way you can change something is multiplying by 1. Because this term right here, if we multiply it or add anything else, it's going to change its value. But if we multiply by 1, it's just multiplying by itself. So, now think of 1 as any number divided by itself. So, this square root of 5 here, 1 is essentially the square root of 5 divided by the square root of 5. Now, we can multiply those two things. So on top, we have the square root of 3 times the square root of 5. If you have two square roots, they can multiply, those two numbers under the square root can multiply, and they both stand to the square root. So 3 times 5 is 15, so the square root of 15. And on the bottom, we have square root of 5 times the square root of 5. Those two can multiply as well to give you the square root of 25. Now, square root of 15, that can't simplify at all. So that stays square root of 15. On the bottom, square root of 25 is 5. Now, we no longer have a square root in the denominator, so we're happy. Now, you can actually even skip this step right here by saying square root of 5 times the square root of 5. If you're multiplying a square root by itself, the two square roots will cancel to leave the number underneath. So square root of anything times itself will be whatever that thing was under the square root. Alright, another one, square root of 8 divided by the square root of 2. Can have a square root in the denominator, so we multiply by 1, or the denominator over the denominator. Square root of 2 over the square root of 2. Now, square root of 8 times the square root of 2 will give us the square root of 16. And square root of 2 times the square root of 2 will give us the square root of 4. Now, square root of 16 divided by the square root of 4, well, square root of 16, you can simplify that. That's 4. And square root of 4 is 2. And 4 divided by 2 is 2. So, that's our answer, and there's no longer a denominator, so we've rationalized the denominator. Now in this case, we have square root of 6 divided by the square root of 10. So again, multiply by 1, or square root of 10 over the square root of 10. On top, that'll give us the square root of 60. And on bottom, that'll give us the square root of 100. So on top, the square root of 60 is not nice to take the square root of, but it can be simplified. So you have to think back to our perfect squares list. What can you divide 60 by? That is a perfect square. The answer to that is 4. So we have the square root of 4, and 60 divided by 4 is 15. And then down bottom, the square root of 100 is 10. So now we can take the square root of 4 is 2, and square root of 15, and divided by 10. Now, we've rationalized the denominator, no more square roots on the bottom. However, we have essentially 2 over 10 here. 2 over 10 can be reduced. So 2 over 10 can reduce to 1 over 5. So 1 times the square root of 15, or just the square root of 15, over 5. So 2 turned into a 1. We don't have to put the 1 there because there's already something else there. And 10 turned into a 5. Now, can you reduce it any more? If all you have left is a square root that cannot be simplified at all on top, then you're done. You cannot simplify, you cannot reduce a square root over a number. Even though you could think 15 divided by 5 is 3, you can't do that because this is a square root and this is not. These two can't reduce each other. They can't combine in any way possible. So this is your final answer. Square root of 15 divided by 5. Alright, one more problem. So in this case, we have square root in the denominator, but we also have whole numbers too. So only slight difference here. So instead of multiplying by the denominator divided by the denominator, you only have to multiply by the square root in the denominator divided by itself. So we have the square root of 11 is on bottom, so we multiply by the square root of 11 over the square root of 11. Now when we do the multiplication here, we only have to multiply the square roots together. The whole numbers stay where they are. So 2 times the square root of 77 and 3 times the square root of 121. Now 77 can't be reduced at all, but 121 can. So 2 over the square root of 77 stays exactly that, and this becomes 3 times the square root of 121 is 11. So now we can multiply those out. 2 over the square root of 77 stays that way, and 3 times 11 is 33. Rationalize the denominator, and 2 and 33 can't reduce each other at all, so we're done. Alright, now time for the sponge. Simplify each expression fully, either by simplifying the square root or rationalizing the denominator. But they must be simplified fully. If they're not simplified fully, you won't get it, and remember, you gotta get all of these right to get a bonus point. But make sure to attempt them all as well. So just simplify as much as you can. And that's it for the lesson. Once again, please make sure to take notes on the entire lesson. Take a picture of your notes with the sponge activity fully attempted. Make sure, go back, rate yourself. And take a picture of your notes. Submit it all to eBackpack. Have a good night.